Okay, so I just wanted to make this quick video going through how to calculate an osculating circle, and I'll point out the same thing I did in the other videos, that we've established in class, all things being equal, your problems get really messy really quickly, which is why we restricted ourselves to kind of helixes and circles and basic vector functions like that. And because in all the other videos I made yesterday, I had already gone through calculating out tangent, normal, tangent, unit tangents and unit normal and unit binormal and all of that. I'm not going to calculate those here because we already did a bunch of them in class. So I'll just assume you know how to do that, and then it really just boils down to understanding what the osculating circle is and then generating an equation for it. And I have this rough picture here where I have some vector r, which then gives me every point along the curve. It ends here. Then at that point on the curve, I can calculate the tangent vector, which is right here, and this is the unit tangent. Then from the unit tangent, perpendicular to it is the normal tangent, the unit normal. And then we have this right here, which is rho, that's not a p, that's rho dotted with n, the normal. And remember, the idea is rho is equal to 1 over the curvature k. And all this is doing is extending the length of the unit normal, and the point you end up with right there becomes the center of your osculating circle. This right here then tells me the radius of the circle, the distance from this point to that point. But ultimately, because we know there are different ways to write circles, and there's kind of different questions you can ask, standard question is, what's the equation for the center of the circle? Same like it was in pre-calc and trig before. But here, I can draw another vector from the origin to the center of the circle, and now I understand graphically that this vector right here is the sum of these two vectors, so then I immediately get that C of t is equal to r of t plus rho of t dotted with n of t. And now again, for the purposes of this, we're going to use a nice simple r of t, and we're going to assume that we already know the tangent and the normal and all, and we've calculated all that. I've already done it on other videos, so I'm not going to bother doing it here. So for this one, let's see. Where's my good one? Right here. Get them all separate. Okay. So suppose we're told r of t is equal to 2 cosine t, 2 sine t, t. A helix, the radius 2. And I want to find this find the osculating circle at t equal to pi over 4. So first, you can find, and we've already found these, so I'm not going to do it here, the unit tangent. For this one, it's 1 over root 5 times negative 2 sine t, 2 cosine t, 1. From that, I can get the unit normal, which for this was negative cosine t, negative sine t, 0. And for the helix, we had an equation. We said the curvature was equal to r over r squared plus gamma squared, which for us, r is the radius, which is 2. So it's 2 over 2 squared 4, plus gamma, which was the coefficient here, which is just 1. And we get 2 over 5. And again, I've already calculated this stuff in other videos, so I'm not going to redo it here and waste time. But as long as we know that, the osculating circle is pretty straightforward because I have the form of the equation right here. C of t is equal to r of t, which is 2 cosine t, 2 sine t, t. And now I'm going to have to erase my picture to get room to write everything out. But plus rho of t, rho, like we had over here, is the reciprocal of k. So flip that, you get 5 over 2 times n of t, which is negative cosine t, negative sine t, 0. That's your equation right there. But we can manipulate this out, plug everything in. I want this at t equal to pi over 4. So it's 2 times cosine of pi over 4, which is root 2 over 2. 2 times sine of pi over 4, which is root 2 over 2. Pi over 4 plus 5 halves times negative cosine of pi over 4, which is negative root 2 over 2. Negative sine of pi over 4, which is negative root 2 over 2. And that's still 0. And now I can just combine that whole thing out into one term. And it would be, let's see, the first term, here the 2's would cancel, so I'd end up with root 2 plus, if I do this, that would be minus 5 root 2 over 4. The next term, the 2's would cancel. I'd get root 2. This would also be minus 5 root 2 over 4. The last term would be pi over 4. And then this term would just be 0 right here. And we would get that. Keep in mind, based on the question you're asked, there's 2 ways to go here, and I kind of deliberately did both. You can told to find the equation for the center of the osculating circle. That's right here. If you actually want the center at the point pi over 4, so where the center of the circle would be, you can just plug in, solve, manipulate, and get that. So you can do it either way, kind of based on what the problem asks for, whether it wants the general equation of the circle or it wants it at a point. That should be everything as far as osculating circles go. 2 things I will point out, and I'm pointing it out on this video because you people made me do all of these, and I was nice enough to do them, and then I deliberately labeled them very obscurely so you couldn't just pick and choose which video you watched. So assuming you actually watched all of them, 2 things. 1, I am not giving you any equations on the exam, which I mentioned repeatedly, but this one I will give you. If I want you to find an osculating circle, I will give you that equation right there. All you'll have to calculate is r, rho, and n. So I won't give you, you'll already know that, but I won't give you the equations for these individually, but I will give you the equation for the circle. So now you only know that if you actually watch these videos. And the other thing, I had said I was going to do videos on torsion, but all things being equal, I don't think I'm going to give you any questions on that on the exam. And if I do, I will give you all of the equations and essentially be plug information into equations and get answer. I'm going back and forth on that as I'm writing your exam. So I'm not going to bother writing an exam for that because I'm not going to bother doing a video for that because if I put it on the exam, I will give you all the equations for that one too. But you only know that if you actually watch all of these. So we'll see how many people know that tomorrow and see if it was worth it to make all of these for you.